Human life is always at great risk on flying aircraft. To control and navigate aircraft, space-based accurate navigation is the need of the day. Air Traffic Control (ATC) is a service provided by ground-based controllers who direct aircraft on the ground and through controlled airspace. The day-to-day problems faced by the air traffic control system are primarily related to the demand placed on the system because of the volume of air traffic and due to weather conditions. Rain, ice, fog or snow on the runway poses problems while landing aircraft. There are a few instances of accidents and incidents which have occurred due to problems of communication with the air traffic control. Isro, along with Airport Authority of India, started a mission to develop a satellite-based navigation system to make life sure and safe in an aircraft while in the air, while landing or during takeoff. The new multitasking satellite Gsat-10 of Isro will provide improved navigation service over the Indian region through GPS-aided geo-augmented navigation Gagan payload. Gagan is a satellite-based augmentation system which uses GPS signals and is especially designed for the aviation industry for safe, reliable and accurate navigation. India's first Gagan payload was orbited by Gsat-8. Now, to add to the glory of its heritage, India is going to launch a new communication satellite, Gsat-10, using cutting-edge space technology. This satellite is equipped with L1 and L5 Gagan transponder for global coverage for the purpose of air traffic navigation. The integration of Gsat-10 with ground elements will pave the way for Gagan system to be fully operationalized after completion of certification activities by 2013. On the basis of its usage, India's telecommunication network is the third largest in the world. The major sectors of the Indian telecommunication industry are telephony, internet and broadcasting. At present in India, nearly 90 crore mobile users, 21 crore internet users and 4 crore DTH users require a state-of-the-art communication satellite to feed their requirements of high-quality, uninterrupted connectivity. The demand on telecommunication services has seen rapid growth in the past 1 decade. To meet this new generation communication requirement, Gsat-10 will also carry 12 numbers of normal C-band, 6 numbers of lower extended C-band transponders, 12 numbers of high-power Ku-band transponders and Ku-band beacon transmitter payloads for India mainland and Andaman and Nicobar Island coverage. Communication satellites provide one of the most important aspects of telecommunication infrastructure called communication transponders. ISRO's Space Applications Center builds transponders for all the INSAT and GSAT series of satellites. Modern communication satellites use a variety of orbits, including geostationary orbits, Molniya orbits, elliptical orbits, and low polar and non-polar Earth orbits. For fixed point-to-point services, communication satellites provide a microwave radio relay technology complementary to that of communication cables. They are also used for mobile applications such as communications to ships, aircrafts, as well as for TV and radio broadcasting. The Indian space program has now taken an emphatic step into the arena of revolutionized communication. In ISRO's 101st mission, communication satellite Gsat-10 will be launched by the Ariane 5 carrier rocket Gsat-10 spacecraft is a 3-axis body-stabilized geostationary satellite based on Isro's I3K structure, and its bus capabilities are fully exploited with respect to accommodation, power generation, thermal management, etc. Gsat-10 carries 30 transponders for communication services. The normal C-band transponders will provide services for the Indian mainland and the region of Western Asia. The extended C-band transponders will cater services for the Indian mainland and the island regions. The Ku-band payloads will beam services over the Indian mainland and the islands of Andaman and Car Nicobar. All the transponders will have a usable bandwidth of 36 MHz. Transmitting and receiving functions of 12 fixed satellite service coverage are achieved through a dual-gridded antenna reflector CDGR mounted onto the east side of the Gsat-10 spacecraft. CDGR will fly for the first time on Gsat-10, establishing an ingenious development in India's space program. Payload testing was completed at Communication Systems Laboratory, Space Application Center, Ahmedabad, and thereafter integrated with the spacecraft. Detailed tests and evaluations were carried out at ISAC, Bangalore. The spacecraft Gsat-10 was airlifted to Kourou and safely received by the European Space Agency in French Guiana. The multitasking Gsat-10 spacecraft underwent an in-depth checkout before its liftoff at Arianespace in French Guiana. Gsat-10 spacecraft carries communication transponders and provides services for a minimum operational life of 15 years. Its liftoff mass is 3,400 kgs. MCF at Hassan has the mandate to carry out mission operations of the nation's geosynchronous spacecraft and has to support and sustain these spacecraft operations right from launch and early orbit phase LEOP through the end of the mission. ISRO's 101st mission, Gsat-10, will be the hallmark of the Indian space program to propel every citizen into the new dawn of futuristic communications using advanced technologies for the development of society.